Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Just myself this week. Brian is actually tied up with some work commitments, but wanted to kind of go in a slightly different direction this week. We've talked about it here and there on the show, but we've never been able to really dig deep into the subject of AI, artificial intelligence, and got somebody on the show that is, I think, going to be a great introduction to this and a great guest to be able to kind of take us through what's kind of really been evolving here and what has really turned into a very, very fast and interesting industry. We've got Dave Cahill, VP of Sales and Marketing at Bonsai. How you doing, Dave?
I'm doing great, Aaron. Thanks for having me.
Absolutely. And so for those that kind of follow the industry, they will very much remember you and hopefully the two of us working together in our Solid Fire days. So it was nice to see you kind of go off and go, you know what, I'm going to go do something really, really different here.
Yeah. Well, as much as I loved our time together, it was a chance for me to go dive into a completely new space for me personally, and couldn't be happier for it.
Yeah, absolutely. So we'll start right off with that. Tell everyone a little bit about Bonsai and really at the heart of what problem are you trying to solve in the industry right now?
Yeah, sure. So Bonsai sits squarely at the intersection of AI and developer productivity. There's this incredibly powerful technology and tools and techniques that is AI, yet in a lot of cases it's inaccessible to the broader software developer community, developers, subject matter experts, et cetera. What we're trying to do at Bonsai is build a platform that enables developers to build AI without getting into the depths of machine learning or requiring an advanced degree in mathematics. And really the way we go about doing that is providing them both the tools and the technology to work at a higher level of abstraction and enable them to put to use their expertise, existing expertise in domain knowledge around particular areas versus having to get into the weeds of AI and machine learning in order to build intelligence models for a particular use case that they're going after.
Yeah. And so I've been digging into it a lot, and you really kind of connected some dots for me and a little bit made the light bulb go off and go, okay, I see what's going on there. And so, but in order to get there, we probably need to start at a higher level and work our way down. And so let's do that for a little bit of tell everyone, like for me personally, whenever I think about AI, I think about like, okay, it's the robots, right? Or it's, something related to that. When what I was really found interesting in researching a lot of this was most of the time, this isn't necessarily what's going on. It's really more about sensors. It's about industrial AI. It's about a ton of data flowing into those sensors and that ability to kind of make more accurate decisions faster. Is that more of a way to look at it than evil robots that are all going to kill us?
So I think there's different ways you can define AI, and a lot of what gets the press or media's attention and starts to scare people is this idea of general AI or strong AI, and that's that more general purpose robots taking over the world and killing all of us sentiment. But I think that's certainly years off. The more near-term applications of AI are sometimes referred to as narrow AI, and that's really the where you're seeing a lot of the innovations happen today across a spectrum or a wide range of applications. Across that range, then you have to then dissect even further in terms of the types of use cases or applications that you're trying to build intelligence into. A lot of what the press and media covers is consumer B2C style use cases or very data-centric style use cases. I sometimes refer to them offhand as toy problems. They tend to be like sentiment analysis or chatbots or virtual assistants and get a lot of coverage in the tech press. Or in a lot of cases, it's very heavy data analysis. It's the kind of extension of big data, taking all this data that you have and then trying to make sense of it and apply greater degrees of intelligence to it. or the needle in the haystack problem. There's this giant data lake, and you need to find the artifact or find the intelligence you can glean from that particular set of data. But that's only one aspect of AI. If you look across the entire spectrum, we talk about data analysis being at one side, all the way at the other end is full-on automation, and sometimes what we refer to as control or optimization problems. This is where use cases like advanced robotics come into play, autonomous vehicles, dark factories, but also what you alluded to, smart sensors, smart meters, smart grids. And these are oftentimes, not just automation problems, but also optimization, getting all of this data and making sense of it and driving intelligent decisions into the business as a result of what those sensors are telling you. And that's a massive area where AI can add value on top of the data sets or expertise that organizations already have in place today. Yeah.
So, and you mentioned in a recent blog post about kind of the toy problem, if you will, and kind of AI use cases in general. And you also went into that range that you were talking about. And in there, you mentioned from augmentation to autonomy. And for me also, prior to this, one of the big things I've always thought of, and maybe it's just because they spend so much money on it at this point, is IBM and Watson. Really being kind of one of almost pioneers of all of this, right? And the big problem I always had when I was thinking about Watson and specifically was, okay, that's great. You have this thing that is the Watson, but it isn't necessarily, at least originally wasn't necessarily able to be really like practically applied in a lot of places because you always had to have like a connection to Watson, right? And there was this idea of like, okay, how do you democratize, if you will, this AI? And so Mark Hammond, the founder and CEO, really talks a lot about this democratization of AI. And what does he really mean by that in your words?
So what Mark's getting from our perspective is AI is incredibly complex and typically requires an advanced degree for you to be able to work at that low level. We talk a lot about the numbers or the big gap in the market. There's 18,000 data scientists. There's 20 million plus software developers. In order for AI to really become a part of all hardware, software, and services globally, it needs to be more accessible to a broader audience. There needs to be tools and technologies that these audiences can use without having to go back and get a PhD in advanced mathematics in order to be able to do that. And so what Mark is really getting at from a democratization perspective is, how do we open up AI as a tool and an enabler to business, not by requiring that everyone learn the low-level mechanics of AI, but creating layers of abstraction that expose a higher level tooling to developers and subject matter experts to work at a level that they're familiar with and unlock the power of AI underneath that. And that's really, there's really two ways to go about doing that. But this is the way that, Mark and Keen, our co-founders, their vision was, what does that tooling and what does that platform look like that opens up and makes the technology accessible to a much wider audience?
Yeah, and for me, that was a bit of a light bulb moment, because Mark had also mentioned AI really becoming this low-level toolkit. Like you were saying, there's so few specialized data scientists, if you will, but there is so many developers, and it almost is a very similar effect to years and years and years ago, this idea of something as simple as databases. Every major application has some kind of database because you have to store data. That's just the way it is. But at the same time, no one writes databases anymore. Everyone will typically call some kind of database. That's just the natural progression. And that was a way of, okay, this is a major component of most applications, but I don't want to rewrite that. I want to focus on what is valuable for the business. And so it took me a while to wrap my head when it first mentioned of like, oh yeah, it's like AI and databases. I'm like, huh? But if you say, okay, it's a toolkit, right? And the same way no one builds a database anymore, are you really then kind of saying folks won't build AIs in the future, even though they potentially are today?
Well, so I think people will absolutely build intelligence and build AIs. The question is really what level are you asking them to build at? And there will no doubt be continued innovation at the algorithms and low-level libraries, right? So there's TensorFlow, there's Caffe, there's Theano, there's Torch, there's MXNet, and the large, the Amazons, the Facebooks, the Microsofts, they all have a different flavor of algorithms and libraries that they're supporting and getting behind. And then there's academia as well. And that's a very important layer of the stack. And you will continue to see innovations absolutely happen there. And these are what really, these are the algorithms that drive a lot of the low-level machine learning. What we're really talking about is, how do you kind of build that layer of abstraction so that others that aren't versed in that low-level technology can take advantage of it, leveraging their existing expertise. And so when we talk about this abstraction, it's not a replacement for those low-level algorithms and libraries. It's a perfect complement. It's a translation layer, if you will, that can exploit the power of machine learning algorithms and libraries, but not have to work at that low level. Another example that Mark uses a lot is mobile. Mobile developers are no longer expected to understand transistor to transistor logic at the hardware level.
Right.
It's kind of that, it's the exact same, let's provide an abstraction for people to work at, to codify their expertise, to solve particular specific business problems, as opposed to spending their time trying to become an expert at these really complex algorithms and libraries.
Yeah, it reminds me of way back when, and my super early days of learning computers and programming way back when, and I won't say exactly when because it's a while ago now, but learning assembly language, right? You had to learn down to the kind of register level to really be able to be fast and be optimized, and of course over time you had abstraction languages that kind of make all that go away. So that definitely kind of reminds me of that as well. You mentioned TensorFlow. TensorFlow comes up a lot here recently, and is definitely kind of one of the up and coming buzzwords. When Brian and I were at the Google Next conference, there was definitely a lot of buzz around that, a lot of talk in the keynotes about it, a lot of out on the show floor about that. And I know you guys have kind of an integration. I would assume it's on top of TensorFlow. Can you talk a little bit about that, of like how would that might help folks with a little bit of a use case example of how does Bonsai and TensorFlow, for example, work together?
Yeah, so it's a good question. So TensorFlow is a lower level library, and underneath that set of algorithms, or sometimes you'll hear them referred to as a toolkit. And so what we do is provide let's say the developer, the subject matter expert, or even the data scientist, a special purpose programming language that allows them to codify the concepts that they want the system to learn, and how to teach them, and the various training sources they're going to use to teach them. Those could be simulations, or they could be data. And we talk about that technique as machine teaching, because you're really empowering these developers to teach. That programming language is then fed into the Bonsai AI engine, and that's where the engine starts to manage and is pairing this programming with the low-level state-of-the-art machine learning libraries like TensorFlow and various techniques like reinforcement learning. And so you take the program the developer has built plus those low-level techniques, they together work to generate and train the most appropriate model for the particular problem you're trying to solve, particular prediction you're trying to make, or variable you're trying to optimize for. And so it's really taking those two things together to get a better outcome, a more business or application-specific outcome than you would if you use them otherwise. And a lot of that management and automation of those low-level techniques is where Bonsai comes into play to help keep the developer from having to work at that level, and instead to get to work at that higher level with our programming language.
And what are some of those kind of early Bonsai specific use cases that are kind of popping out? What are folks kind of latching onto?
Yeah, it's interesting. I mean, because a lot of people, the vision of the company is absolutely a platform vision, and we believe over time that and have built a lot of the major components you need from a platform perspective, but in implementation, we absolutely are convicted to find the killer applications that the platform will initially address. And for us, there's really two. One is control, and the other is optimization. And on the control side, that's building greater automation, things like robotic control into these intelligent systems, often industrial systems. And the other is optimization. There's a set of behaviors and constraints and variables that drives a particular system. Think like supply chain or logistics or smart grid or smart sensors or something like that. How do you build AI models to enhance the decision support to better optimize these intelligent systems? And so, relative to kind of the data analysis and consumer-centric use cases we talked about at the start of the show, what we're going after is what I talk about as more industrial strength or industrial AI style use cases around these intelligent systems that benefit from greater control or optimization.
And I always love to ask the flip side question to that. So if that's where folks are going, especially when it comes to something like this, which is so new in the industry, when you're talking to industrial, when you're talking to enterprise, what are some of the big challenges that you have to overcome, whether it's a perception, whether it's a use case? Like, what are the things that you're like, oh man, we're struggling with this one again, kind of things? What are some of the typical challenges you see?
Yeah, I mean, the first challenge is AI by itself is so nascent that people definitely are looking at it as a strategic tool or technology or asset that they can use to potentially help impact their business. They're trying to figure out where are they best suited to leverage AI within the business. What are the right applications for them? And so in some cases, you simply have to help sort through the maze of potential use cases that the customers are looking at to find the control and optimization problems. We try and solve some of that by targeting the verticals that we believe are focused on things like supply chain, robotics, logistics, energy, utilities, manufacturing, such that when we talk to these customers, we know that inside there's a supply chain to be optimized. There's fleet logistics. There may be well drilling operations to be optimized or something like that, or manufacturing robotics or industrial robotics. So we very much look to the vertical to help inform our accuracy around use case targeting. And then once you're in the right verticals, it's about understanding where their data is coming from. How are they, how would they potentially train an AI? What type of data sources would they use? One of the things that the system supports today is simulations as the primary training source. And so while a lot of people talk about very data-centric AI use cases and taking large piles of existing data, in a lot of cases, these large industrial systems have dynamic and unconstrained problem spaces where you don't necessarily have a production model of that system to generate data from, or you're not a large-scale enterprise that just has these massive data sets sitting around. In that case, you need to offset that with simulators. And so, you think of flight simulators or supply chain simulation tools, robotic simulators. You have to find, companies that use these simulators or are receptive to using them as an alternative to training their AIs. And then last is just the available techniques and familiarity. And there's absolutely a learning curve that we have to help offset, whether it be helping them understand the nuances of reinforcement learning and whether or not there's a particular problem that can be solved with something like reinforcement learning, or other areas of AI that they just need to fill in the gaps on. We absolutely understand that, and a lot of times work the customer through these problems as part of the qualification to ensure we're both on the same page with the applications we're trying to address today.
Yeah, and that really helps with if you go out to the website. There's kind of three main phases to the Bonsai brains, as you're calling them. There's build, teach, and use. And if you don't mind, explain folks kind of what that means. And then, but before you do, let me kind of use this as an example, because it's actually on your website, and I thought it was pretty cool. Is basically a brain is this, taking this developer and writing some code and allowing it to call the AI, if you will, if I'm figuring that out correctly. And you do it to play an old style breakout game, like the block breaker games. And you show a video of a brain that basically teached itself to play Breakout and to optimize for a high score. So obviously, if you're optimizing for a high score, it's learning to play better and to play longer. And it was really neat to see how it kind of was adapting, if you will, over time. But it was, I assume, going through each of these things. So, tell everyone a little bit about this build, teach, use model. And then also maybe, because like you were saying earlier, games kind of help folks understand things, but maybe what's a really cool cutting edge use case that somebody brought to you that you didn't expect?
Yeah, sure. So build, teach, use is really the way we've tried to simplify, the application development lifecycle, or as it relates to an AI model. And really what we're referring to here is the construction of an AI model that will ultimately be used and plugged into a particular hardware or software application. And so, build is around providing the tools to outline the concepts and schemes that you're actually trying to teach the model. And for that, we provide our special purpose programming language known as Inkling, where a developer would codify the concepts they want a system to learn, specify, how they're going to teach them, and the training sources required. We talked about this a bit earlier. It's like simulations or data. You're basically kind of framing up exactly what you're trying to construct with the system. The teach phase is where we hand off everything you've established and outlined in the build phase to the AI engine. And really, you feed the AI engine all of those concepts and training sources, et cetera. And that's where the system works to train and teach the AI model the exact problems that you're trying to solve. The system under the covers abstracts all of the management of the low-level libraries and algorithms like TensorFlow and others and various techniques, and optimizes any particular algorithm based on the model that you're trying to build. What comes out the other side of that engine is a high-level model that can then be connected into your hardware or software application through Bonsai provided libraries. And so just as a database is connected into your application, a brain, as we refer to it as, can be connected into your hardware or software application and then is available for ongoing debugging and refinement and can be repurposed for use in other applications. And so from a lifecycle perspective, it's about really covering all phases of that, from programming to runtime to management. We handle a lot of those pieces or give you the tools to handle those pieces so that you're not having to cobble together various technologies and use and move off of something else for runtime and look to something else for management. We've really got a developer or data scientist or subject matter expert, well covered in that regard.
Yeah. And any surprises of use cases? Anybody bring you something that the folks were like, hadn't really thought of that?
Well, we had this is the interesting part about AI is there's a lot of very generic AI use cases that can be solved with like an API style approach or perhaps a statistical analysis package. And what's interesting about some of these industrial use cases is the uniqueness of them. And really you have enterprises that don't necessarily, image recognition is interesting, but it's not a business or domain specific problem they're trying to solve. And some of them are humorous, right? There's one that's one large enterprise looking to optimize licorice extrusion yield. Another is trying to build, and optimize vineyard yield and managing sensors attached to vines, to their vineyard to optimize weather patterns against that. Others are looking to build smart robots to handle a lot of their warehouse operations. And so I'd say that the use case spectrum is vast, but the one thing that is the common denominator here is the uniqueness of some of these enterprise use cases relative to kind of what you and I see on a daily, basis around speech or image, or facial recognition style use cases.
Yeah, it makes perfect sense, and it goes into kind of you've announced an extension of another round of funding, extension of your A round, if I remember correctly, as well as kind of an early access program. And so, why don't you tell everyone a little bit about that too? Because it's really fascinating to me that I think it probably further emphasizes this fact.
Yes, absolutely. So, yeah, we're definitely excited about the recent extension to the round. For a few reasons. I mean, not only does it, add more funding for us to realize the vision, but the investors in the round. So the extension to the recent A round includes Microsoft Ventures, ABB, Samsung, and Siemens. And the excitement on my part is really, these are large, in most cases, industrial enterprises looking for AI solutions that can address their specific problems. And for us, it's a great endorsement of the problems we're trying to solve at that end of the AI spectrum. And with the funding, we've launched this early access program that allows us to engage enterprises and large enterprises that are looking to build AI and leverage AI in their business and take them through really an eval and POC phase to scope and qualify and design AI models that are specific to their business using the Bonsai platform. And the funding allows us just to accelerate, both product innovations and customer engagement to take customers through that program faster and get them realizing, real business impact from these AI models faster than they could otherwise.
Nice. Fantastic. So we're kind of hitting our limit on time here. We're going to kind of close this out a little bit here. Dave, where can everyone follow you, follow Bonsai, kind of figure out what's going on, go take a look at the documentation, etc.?
Yeah, sure. So me personally, I'm on Twitter at DKHill8. From a company perspective, it's bonsbonds.ai is the easiest way to find us. On that page, you'll be able to, we've tried to make it so if you're a developer or looking for technical content, you can quickly head towards the docs and choose your own adventure. If you're looking for higher level how it works, explainer videos, other things like that, looking to understand, at a higher level what Bonsai is and does, there's content there for you as well. Certainly, if you don't get what you need or can't find what you're looking for, reach out to me directly, and I will do whatever I can to fill in the gaps.
Awesome. Sounds great. Well, Dave, I certainly appreciate your time. It was great talking to you again. And on behalf of Brian, who couldn't make it this week, thank you very much for your time. And thanks, everyone, for listening. We'll talk to you next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.